All right, and welcome back. So today we are going to be talking about yet another way to solve quadratic equations. This time we're going to be talking about what is called the quadratic formula. And within the quadratic formula, we have what is called the discriminant. Now, the quadratic formula, it will always produce the x values if we're able to have them. And that's because, well, it's a formula. And actually, the quadratic formula is derived by completing the square. But I'll show you all that a little bit later in a separate video. So we can use this quadratic formula to help us solve for x at any possible time that we could have x values. It can get a little bit complicated, but it will produce the correct answers bearing we are doing the correct algebra. So let's talk about the quadratic formula. But before we do that, let's just think about the song Pop Goes the Weasel. Da 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 da. We can remember the quadratic formula by knowing the song Pop Goes the Weasel. Let me show you what I mean. So the quadratic formula can be used to solve, again, any quadratic equation. And here's the formula up top. Let me highlight it for you. That way we know exactly what we're talking about. That's the quadratic formula. We have x is equal to opposite of b plus or minus the square root of b squared minus 4ac. That's all over 2a. And the way we can remember it again is using the song Pop Goes the Weasel. So let me give you a embarrassing way or an embarrassing rendition of this. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So you can use Pop Goes the Weasel to help you remember the quadratic formula. And we're going to be solving 2x squared minus 5x minus 12 is equal to 0 using the quadratic formula. So let's go through the steps on how to do that. We first need to identify our a, b, and c values. A is 2, b is negative 5, and c is negative 12. Let's highlight those. That way we can plug them in and hopefully get a visual reference as to where they belong. So we're going to substitute into the quadratic formula. Now again, I'm going to try to highlight this for you. So x is equal to the opposite of b, or b is negative 5. So it's going to be the opposite of negative 5, plus or minus the square root of b squared minus 4 times a times c. And that's all going to be divided by 2a. From here, we can simplify, and we're going to end up with 5 plus or minus 11 divided by 4. So now we're going to have two possible answers. We're going to have 5 plus 11 over 4 or 5 minus 11 over 4. And when we solve, we're going to get that x is equal to 4 or x is equal to negative 3 over 2. So by having this quadratic formula, we can substitute in a, b, and c, and then we're going to solve to get x. I just realized I made a quick boo-boo when it came to highlighting. I apologize for that. 2 is A, not yellow. They should have been green. All right, kiddos, with this in mind, please work on problems 1 through 4 on the guided notes and resume when you're ready to talk about the discriminant. So the discriminant of a quadratic equation is b squared minus 4ac. So just to show you where it is within the actual quadratic formula, let me rewrite it for you. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So the discriminant is what's underneath our radical. This is a part that's going to be underneath the radical. And this is going to tell us how many real solutions are going to be within our quadratic equation. And that's because we're dealing with a square root. So when we have square roots, we have 3 possible answers. If the value underneath the square root, our discriminant, is greater than 0, then that equation is going to have 2 real solutions. If our discriminant is equal to 0, it's going to have one real solution. And if our discriminant is less than 0, it's going to have no real solutions, because for our case, we cannot have a negative inside of our radical. That's why we have 0 real solutions if that occurs. But let's go through a couple of examples to see if we can identify how many real solutions there are going to be. So let's find the number of real solutions of 4x squared minus 8x plus 5 is equal to 0 using the discriminant. Let's recall that our discriminant is b squared minus 4ac, so we need to know what a, b, and c are. We can substitute it into b squared minus 4ac. Again, I'm going to highlight this first one for you. A will be equal to 4, b will be equal to negative 8, and c will be equal to 5. So we're going to substitute into b squared minus 4ac. As we do so, we get negative 8 squared minus 4 times a, which is 4, times c, which is 5. We're going to simplify, and we're going to see that 64 minus 80 is negative 16. So our discriminant turns out to be negative, which means there's going to be no real solutions. Because if this was back in our quadratic formula, we'd have the square root of negative 16. And right now, we can't find that. That's not going to have any real solutions. So since there are no real solutions, this also is not going to cross over the x-axis. We don't have any possible zeros, any possible values of x, because there are no real solutions. Let's find the number of real solutions of 9x squared minus 49 is equal to 0, again, using the discriminant. We want to identify our a, b, and c. Notice how we do not have a b term. We are so used to seeing ax squared plus bx plus c is equal to 0. But notice that there is no bx term. There is no linear term in this equation. So therefore, b is going to be equal to 0, because 0 times x is 0, which is why it does not appear. We're going to substitute into the discriminant, which is b squared minus 4ac, and we're going to simplify. We're going to end up with 1764. So since it's positive, that means there are going to be 2 real solutions. Awesome. With this in mind, please work on problems 5 through 8 on the guided notes. Y'all are working super duper hard. Keep up the great work. Keep making yourself proud. Let me know if you have any questions, and I'll talk to you soon.